What's up guys, welcome to another video. In this one we will be finding a closed form for the zeta function evaluated at 4. Now if you don't remember what the zeta function is, I've put up a little reminder here. It's the sum n greater or equal to 1 of 1 by n to the s, where s is a complex number with real part greater than 1. Now remember that thanks to Euler, we know that zeta of 2 is pi squared by 6, and we're going to be able to use that fact later. Now what we want, as I said, is zeta of 4, which is the sum n being greater or equal to 1 of 1 by n to the 4th. And to achieve that, I want to do something that seems completely unrelated, and that is to find the Fourier transform of x to the 4th power. Now if you don't know what the Fourier transform is, it's a way to represent a function, say f of x, as some initial value, we'll call it a naught, plus a sum, n being greater or equal to 1, of some coefficients, a n times the cosine of nx, plus other coefficients called a bn times the sine of nx. And what this does is it represents a function f of x on a certain interval. By the way, this would be on some interval negative L, L. And it represents it as a sum of sine and cosine waves. It's kind of like Taylor series. If you remember Taylor series, you represent a function as an infinite polynomial sum of waves. Now to find these coefficients and that a naught value, we have a couple formulas, namely a0 is equal to 1 by 2l, and this is the length of this interval, times the integral from negative L to L of f of x dx. So this is pretty easy to evaluate. Now the a sub n's, they would be 1 by L times the integral from negative L to L of f of x times the cosine of nx dx, and similarly the b sub n's would be 1 by L integral from negative L to L of f of x times the sine of n times x dx. And as I said earlier, what we're going to do is setting f of x to be x to the 4th power, and we're going to take it on the interval negative pi. Now I know this may look very abstract, and it does, but later down the calculations we're going to find exactly the sum we're looking for. So what I'm going to do now is calculate the a naught, a n, and bn for this function. So we have that a naught is 1 by, it would be 2l, but l in our case is pi, so 1 by 2 pi integral from negative pi to pi of x to the 4th power dx. Now this obviously evaluates to x to the 5th over 5, and when we plug in pi and negative pi, we would get 2 pi to the 5th over 5, and we're dividing by 2 pi, so a naught would be pi to the 4th over 5. Now we can find a sub n. A sub n would be 1 by L, so 1 by pi, integral from negative pi to pi of x to the 4th times cosine of n times x dx. Now this integral is not really that difficult, it's just integration by parts a couple times, but it's pretty annoying honestly, and I didn't want to bore you guys to death, so I went ahead and asked Wolfram Alpha to compute this integral, and the result is 8 pi n times pi squared n squared minus 6 times the cosine of pi times n plus 2 pi to the 4th n to the 4th minus 12 pi squared n squared plus 24. and all of this times the sine of pi n. And before I do this big division bar, notice that the sine of pi times n, in our case, n is going to be an integer ranging from 1 to infinity. So the sine of pi times n is going to be like sine pi and then sine 2 pi and so on and so forth. And it's always 0. So this whole chunk goes to 0. And similarly, the cosine of pi times n is either, if you picture the circle, it's either the cosine of pi here, and then 2 pi, and then 3 pi, and 4 pi, and it just alternates between both. So it's the same as saying negative 1 to the n. And all of this is divided by n to the 5th. Now notice we can cancel an n here, leaving us with n to the 4th. And we had this 1 by pi here, which is going to cancel out this pi. Alright, therefore we have a sub n equal to 8 times negative 1 to the n times, and I'm going to split this into two fractions. So we have pi squared over n squared minus 6 over n to the 4th. And you might see here where our zeta of 4 will come in later. Now all that's left to find is b sub n. Now b sub n is this expression here, although if we plug x to the 4th power for f of x, we get this integral. And notice that this is an odd function, and we're integrating it over a symmetric interval, meaning the whole thing just goes to 0. And that also implies that this whole part of the sum is going to be 0. So b sub n equals 0. Now we have all of the pieces and we can put them back together. So putting everything together, we have that x to the 4th is equal to a naught, which was pi to the 4th over 5, plus the sum n being greater or equal to 1 of a sub n, which is defined right up here. That is 8 times negative 1 to the n times pi squared by n squared minus 6 by n to the 4th. And we need to multiply that with cosine of nx. Now what I want to do is plug in a certain value for x that'll help us out. And the appropriate value here would be pi. So when we set x to be equal to pi, we get pi to the 4th on the left hand side. And I might as well subtract this quantity on both sides while I'm at it. So we're going to get 4 pi to the 4th over 5 equal to, now plugging pi into this would give us cosine of n times pi, which like I said earlier is just negative 1 to the n. And we have another negative 1 to the n right here. So those two would just cancel out and give us 1. So we'd have 8 times the sum n being greater or equal to 1. And I'm going to split this into two sums to make things easier. So we're going to get actually pi squared outside times 1 by n squared minus 8 times 6 times the sum n greater or equal to 1 of 1 by n to the 4th. And here, notice that this is precisely what we're looking for. It is zeta of 4. And this is zeta of 2, which we know is pi squared by 6. So now it's just a matter of isolating our zeta of 4. I'm going to do so by subtracting this quantity on both sides. So we're going to get 8 times 6. This is 48 times zeta of 4. And I'm actually going to leave it at 8 times 6 for now. And you'll see why later. And that would be 8 pi squared times this quantity, which would be pi to the 4th on top, 4 here, and a 3 here. Minus 4 pi to the 4th over 5. Now we're going to want to get these into a common denominator. So we have 8 times 6 times zeta. That's an ugly zeta. Even uglier. Zeta of 4. I'm going to multiply this left fraction by 5, so we're going to get 20 pi to the 4th over 15 minus, and multiply this one by 3, so 12 pi to the 4th over 15, and overall this just gives us 8 pi to the 4th over 15. So we have 8 pi to the 4th over 15. Now you might see why I left this as 8 times 6. We can clearly divide by 8 on both sides and multiply by 1/6, giving us the final result that zeta of 4, which was the sum n greater or equal to 1 of 1 by n to the 4th, is pi to the 4th over 90. And that's a pretty sick result. Now I hope you enjoyed the video. If you did, make sure to leave a like and subscribe, as it would really help me out. Again, if you have suggestions or anything you would like me to know, just let me know in the comments. And yeah, have a good one.